conditional probability is the likelihood of an event or outcome occurring based on something that has already occurred. Okay. Like for example, A is the event of getting an even number. B was the event of getting a number that is greater than 2. So if I write what is the probability of B occurring if it is already told to me that A has occurred. It is already given to me that A has already happened. So I have already got either 2, 4, or 6. Now, what is the probability that I am getting a number that is greater than 2? So therefore, it can only be 4 and 6. So out of 4 or 6, that is 2 outcomes out of 3. So getting a 4 and 6 will ensure that B also is satisfied. And total is 3 outcomes. This is nothing but probability A intersection B divided by probability A. PA intersection B is getting 4 and 6, and PA is getting 3 out of 6. This is nothing but 2 by 3, which we already have here. And we have here an illustration wherein in a group of 100 car buyers, 40 bought alarm systems, 30 purchased bucket seats, and 20 purchased an alarm system and bucket seats. If a car buyer at random is chosen, bought an alarm system. So a person has already bought an alarm system. So 40, I am already within 40. What is the probability that the person also bought bucket seats? 20 people out of the 40 has bought bucket seats and alarm systems. So 20 by 40, which is equal to half. That is what is the answer to this particular question. Okay. So conditional probability is nothing but A has already occurred. Now, what is the probability of B occurring? So A, or the number of outcomes of A, comes in the denominator. Number of favorable outcomes for A and number of favorable outcomes of A and B, because A has already occurred. So A and B together occur. That will be in the numerator, and only the outcomes favorable for A will be in the denominator. Now, conditional probability will tell you many things. That if I want to find out the conditional probability of B given A, when A and B are mutually exclusive, B given A will be 0 in the case of mutually exclusive events. And this is equal to simply PB in the case of independent events. Why it is only B? Because A has no bearing on B. Whether A has occurred or not will not affect the probability of B at all. You can also identify that, okay, these are the results by putting in the mathematical result that we have already seen. So in case of mutually exclusive, P intersection B is equal to 0. So put this as 0. 0 by anything is 0. And in independent, this is PA into PB divided by PA. If PA is not equal to 0, this cancels out and this is simply PB. So in case of independent events, PB given A is simply PB. Bayes theorem as a part of conditional probability. PB given A is nothing but PA intersection B divided by PA. And PA given B is basically PA intersection B divided by PB. Or in result, PA intersection B is equal to basically PB given A into PA, which is also the same as PA given B into PB. So we can write PA given B is PB given A into PA by PB, or PB given A is PA given B into PB by PA. A conditional probability can be expressed in terms of another conditional probability in this very simple way. And these formulas, once used, constitute the result of the Bayes theorem. PA given B is PB given A into PA by PB.